CIET NCERT presents Audiobook of Science for Class 7 entitled Science. This is the lesson 4, Heat, from page 35 to page 48. Let's listen to the lesson 4, Heat. Page 35. In chapter 3, you learned that woolen clothes are made from animal fibers. You also know that cotton clothes are made from plant fibers. We wear woolen clothes during winters when it is cold outside. Woolen clothes keep us warm. We prefer to wear light-colored cotton clothes when it is hot. These give us a feeling of coolness. You might have wondered why particular types of clothes are suitable for a particular season. In winter, you feel cold inside the house. If you come out in the sun, you feel warm. In summer, you feel hot even inside the house. How do we know whether an object is hot or cold? How do we find out how hot or cold an object is? In this chapter, we shall try to seek answers to some of these questions. 4.1 Hot and Cold. In our day-to-day life, we come across a number of objects. Some of them are hot and some of them are cold. Tea is hot and ice is cold. List some objects you use commonly in table 4.1. Mark these objects as hot or cold. Table 4.1 Hot and Cold Objects. There's a table given here. In this table, there are 3 columns and 4 rows. In column 1, we have object. Column 2 is labeled cold or cool. Column 3 is labeled warm or hot. The objects are ice cream, spoon in a teacup, fruit juice, handle of a frying pan. Warning: do not touch objects which are too hot. Be careful while handling a candle flame or a stove. We see that some objects are cold while some are hot. You also know that some objects are hotter than others while some are colder than others. How do we decide which object is hotter than the other? We often do it by touching the objects. But is our sense of touch reliable? Let us find out. Activity 4.1. Take 3 small tubs or containers. Label them as A, B, and C. Put cold water in container A and hot water in container B. Warning: make sure that water is not so hot that you burn your hand. Figure 4.1. Filling water in 3 containers. A. In this picture, we can see a hand coming from and it is immersed in the container filled with water. B. In this picture, we can see a hand coming from the right direction. This hand is also immersed in the container filled with water. C. In this picture, we can see a pair of hands immersed in a container full of water. Page 36. B. Mix some cold and hot water in container C. Now, dip your left hand in container A and the right hand in container B. After keeping the hands in the two containers for 2 to 3 minutes, put both the hands simultaneously in container C. You can observe this in figure 4.1. Do both the hands get the same feeling? There's a thought bubble given here. A picture of Bojo is next to it. Bojo says, "My left hand tells me that the water in mug C is hot, and the right hand tells me that the same water is cold. What should I conclude?" Bojo's confusion shows that we cannot always rely on our sense of touch to decide whether an object is hot or cold. Sometimes it may deceive us. Then, how do we find out how hot an object really is? A reliable measure of the hotness of an object is its temperature. Temperature is measured by a device called thermometer. 4.2. Measuring temperature. Have you seen a thermometer? Recall that when you or someone else in your family had fever, the temperature was measured by a thermometer. The thermometer that measures our body temperature is called a clinical thermometer. Hold the thermometer in your hand and examine it carefully. If you do not have a thermometer, request a friend to share it with you. A clinical thermometer looks like the one we have in figure 4.2. Figure 4.2. This is the image of a clinical thermometer. A temperature close to 37 degrees Celsius has been recorded on it. A clinical thermometer consists of a long, narrow, uniform glass tube. It has a bulb at one end. This bulb contains mercury. Outside the bulb, a small, shining thread of mercury can be observed. If you can't observe the mercury thread, rotate the thermometer a bit till you can observe it. You will also find a scale on the thermometer. The scale we use is the Celsius scale, indicated by degree Celsius. There's a thought bubble given here. A picture of Bojo is next to it. Bojo wondered which of the two scales shown in figure 4.2 he should read. Paheli told him that India has adopted the Celsius scale and we should read that scale. The other scale with the range 94 to 108 degrees is the Fahrenheit scale, read as degrees Fahrenheit. It was in use earlier. A clinical thermometer reads temperature from 35 degrees Celsius to 42 degrees Celsius. Activity 4.2. Reading a thermometer. Let us learn how to read a thermometer. First, note the temperature difference indicated between the two bigger marks. Also, note down the number of divisions between these marks. These divisions are represented by smaller marks. Suppose the bigger marks read 1 degree and there are 5 divisions between them, then one small division can read 1 by 5 is equal to 0.2 degree Celsius. Page 37. Precautions to be observed while using a clinical thermometer. 1. Thermometer should be washed before and after use, preferably with an antiseptic solution. 2. Ensure that before use the mercury level is below 35 degrees Celsius. 3. read the thermometer keeping the level of mercury along the line of sight. You can observe this in figure 4.3. 4. Handle the thermometer with care. If it hits against some hard object, it can break. 5. Don't hold the thermometer by the bulb while reading it. Now, wash the thermometer, preferably with an antiseptic solution. Hold it firmly and give it a few jerks. The jerks will bring the level of mercury down. Ensure that it falls below 35 degrees Celsius. Now, place the bulb of the thermometer under your tongue. After 1 minute, take the thermometer out and note the reading. This is your body temperature. The temperature should always be stated with its unit, degrees Celsius. What did you record as your body temperature? The normal temperature of human body is 37 degrees Celsius. Note that the temperature is stated with its unit. Figure 4.3. Correct method of reading a clinical thermometer. Here, we can observe a girl closely looking at a thermometer and trying to know her temperature. There's a thought bubble given here. A picture of Paheli is next to it. Paheli measured her body temperature. She got worried as it was not exactly 37 degrees Celsius. Let us try to assure Paheli that there is nothing wrong with her. Activity 4.3. Measure the body temperature of some of your friends, at least 10, with a clinical thermometer. Record your observations as in Table 4.2. Table 4.2. Body temperature of some persons. In this table, you will record the name of the person and his or her body temperature in degrees Celsius. Page 38. Is the body temperature of every person 37 degrees Celsius? The temperature of every person may not be 37 degrees Celsius. It could be slightly higher or slightly lower. Actually, what we call normal temperature is the average body temperature of a large number of healthy persons. The clinical thermometer is designed to measure the temperature of human body only. The temperature of human body normally does not go below 35 degrees Celsius or above 42 degrees Celsius. That is the reason that this thermometer has the range 35 degrees Celsius to 42 degrees Celsius. There's a thought bubble given here. A picture of Bojo is next to it. Bojo got a naughty idea. He wanted to measure the temperature of hot milk using a clinical thermometer. Paheli stopped him from doing so. Caution: do not use a clinical thermometer for measuring the temperature of any object other than the human body. Also avoid keeping the thermometer in the sun or near a flame. It may break. 4.3. Laboratory thermometer. How do we measure the temperature of other objects? For this purpose, there are other thermometers. One such thermometer is known as the laboratory thermometer. This thermometer will be available with your teacher. Observe it carefully and note the highest and the lowest temperature it can measure. The range of a laboratory thermometer is generally from -10 degrees Celsius to 110 degrees Celsius. We can observe this in figure 4.4. Also, as you did in the case of the clinical thermometer, find out how much a small division on this thermometer reads. You would need this information to read the thermometer correctly. Different types of thermometers are used for different purposes. The maximum and minimum temperatures of the previous day reported in weather reports are measured by a thermometer. The maximum and minimum temperatures of the previous day reported in weather reports are measured by a thermometer called the maximum minimum thermometer. Let us now learn how a laboratory thermometer is used. Figure 4.4, a laboratory thermometer. Activity 4.4. Take some tap water in a beaker or a mug. Dip the thermometer in water so that the bulb is immersed in water but does not touch the bottom or the sides of the container. Hold the thermometer vertically. You can observe this in figure 4.5. Observe the movement of mercury in the thermometer. Wait till the mercury thread becomes steady. Page 39. Note the reading. This is the temperature of water at that time. In addition to precautions to be taken while reading a clinical thermometer, the laboratory thermometer 1. Should be kept upright, not tilted, as you can observe in figure 4.5. 2. Bulb should be surrounded from all sides by the substance of which the temperature is to be measured. The bulb should not touch the surface of the container. Figure 4.5. Measuring temperature of water with the laboratory thermometer. In this picture, we can observe a laboratory thermometer immersed in water, that is, inside a container. Compare the temperature of water recorded by each student in the class. Are there any variations in the readings? Discuss the possible reasons. Let us try to answer this question. There's a thought bubble given here. A picture of Bojo is next to it. Bojo now understands why clinical thermometer cannot be used to measure high temperatures, but still wonders whether a laboratory thermometer can be used to measure his body temperature. Activity 4.5. Take some hot water in a beaker or a mug. Dip the thermometer in water. Wait till the mercury thread becomes steady and note the temperature. Now, take out the thermometer from water. Observe carefully what happens now. Do you notice that as soon as you take the thermometer out of water, the level of mercury begins to fall? This means that the temperature must be read while the thermometer is in water. There's a thought bubble given here. A picture of Bojo is next to it. Bojo wonders why the level of mercury should change at all when the bulb of the thermometer is brought in contact with another object. You may recall that while taking your own temperature, you have to take the thermometer out of your mouth to note the reading. Can you then use the laboratory thermometer to measure your body temperature? Obviously, it is not convenient to use the laboratory thermometer for this purpose. Page 40. Why does the mercury not fall or rise in a clinical thermometer when taken out of the mouth? Observe a clinical thermometer again. Do you see a kink near the bulb? You can observe this in figure 4.6. What is the use of the kink? It prevents mercury level from falling on its own. Figure 4.6. A clinical thermometer has a kink on it. There is a lot of concern over the use of mercury in thermometers. Mercury is a toxic substance and is difficult to dispose of if a thermometer breaks. These days, digital thermometers are available which do not use mercury. 4.4. Transfer of heat. You might have observed that a frying pan becomes hot when kept on a flame. It is because the heat passes from the flame to the utensil. When the pan is removed from the fire, it slowly cools down. Why does it cool down? The heat is transferred from the pan to the surroundings. So, you can understand that in both cases, the heat flows from a hotter object to a colder object. In fact, in all cases, heat flows from a hotter object to a colder object. How does heat flow? Let us investigate. There's a thought bubble given here. A picture of Paheli is next to it. Paheli asks, does it mean that heat will not be transferred if the temperature of two objects is the same? Activity 4.6. Take a rod or flat strip of a metal, say of aluminum or iron. Fix a few small wax pieces on the rod. These pieces should be at nearly equal distances. You can observe this in figure 4.7. Clamp the rod to a stand. If you do not find a stand, you can put one end of the rod in between bricks. Now, heat the other end of the rod and observe. What happens to the wax pieces? Do these pieces begin to fall? Which piece falls the first? Do you think that heat is transferred from the end nearest to the flame to the other end? Figure 4.7. Flow of heat through a metal strip. In this figure, we can observe a rod between two bricks. A lit candle is kept beneath the other end of the rod. The wax pieces on the rod are melting. The process by which heat is transferred from the hotter end to the colder end of an object is known as conduction. In solids, generally, the heat is transferred by the process of conduction. Do all substances conduct heat easily? You must have observed that the metallic pan for cooking gas has a plastic or wooden handle. Can you lift a hot pan by holding it from the handle without getting hurt? Activity 4.7. Heat water in a small pan or a beaker. Collect some articles such as a steel spoon, plastic scale, pencil, and divider. Dip one end of each of these articles in hot water. You can observe this in figure 4.8. Wait for a few minutes. Touch the other end. Enter your observation in table 4.3. Figure 4.8. Conduction of heat by different materials. Here, we can observe a beaker filled with hot water. Different items are inside the beaker, such as steel spoon, plastic scale, pencil, and divider. Table 4.3. In this table, there are 3 columns. In the first column, the label is article. In second column, the label is material with which the article is made of. In the third column, the label is Does the other end get hot? Yes or no? An example has also been filled in the table. Article: steel spoon. The material is metal. Does it get hot? Yes. The materials which allow heat to pass through them easily are conductors of heat. For example, aluminum, iron, and copper. The materials which do not allow heat to pass through them easily are poor conductors of heat, such as plastic and wood. Poor conductors are known as insulators. The water and air are poor conductors of heat. Then, how does the heat transfer take place in these substances? Let us find out. Activity 4.8. Take a round bottom flask. If flask is not available, a beaker can be used. Fill it 2/3 with water. Place it on a tripod or make some arrangement to place the flask in such a way that you can heat it by placing a candle below it. Wait till the water in the flask is still. Place a crystal of potassium permanganate at the bottom of the flask gently using a straw. Now heat the water by placing the candle just below the crystal. Write your observation in your notebook and also draw a picture of what you observe. For help, you can observe figure 4.9. When water is heated, the water near the flame gets hot. Hot water rises up. The cold water from the sides moves down towards the source of heat. This water also gets hot and rises, and water from the sides moves down. Page 42. This process continues till the whole water gets heated. This mode of heat transfer is known as convection. How does the heat travel in air? In which direction does the smoke go? The air near the heat source gets hot and rises. The air from the sides comes in to take its place. In this way, the air gets heated. The activity given here confirms the idea. Activity 4.9. Light a candle. Keep one hand above the flame and one hand on the side of the flame. You can observe this in figure 4.10. Do your hands feel equally hot? If not, which hand feels hotter and why? Warning: be careful. Keep your hands at safe distance from the flame so that they do not get burnt. Figure 4.9. Convection of heat in water. In this picture, a container filled with water and potassium permanganate is being heated. Figure 4.10. Transfer of heat by convection in air. In this picture, there's a candle. The candle is lit. A hand is behind the candle. Another hand is above the flame. Notice that towards the top, the air gets heated by convection. Therefore, the hand above the flame feels hot. On the sides, however, there is no convection, and air does not feel as hot as at the top. The people living in the coastal areas experience an interesting phenomenon. During the day, the land gets heated faster than the water. The air over the land becomes hotter and rises up. The cooler air from the sea rushes in towards the land to take its place. The warm air from the land moves towards the sea to complete the cycle. You can observe this in figure 4.11. The air from the sea is called the sea breeze. To receive the cooler sea breeze, the windows of the houses in coastal areas are made to face the sea. At night, it is exactly the reverse. The water cools down more slowly than the land. So, the cool air from the land moves towards the sea. This is called the land breeze. When we come out in the sun, we feel warm. How does the heat from the sun reach us? It cannot reach us by conduction or convection, as there is no medium such as air in most part of the space between the earth and the sun. From the sun, the heat comes to us by another process known as radiation. Page 43. The transfer of heat by radiation does not require any medium. It can take place whether a medium is present or not. When we sit in front of a room heater, we get heat by this process. A hot utensil kept away from the flame cools down as it transfers heat to the surroundings by radiation. Our body too gives heat to the surroundings and receives heat from it by radiation. All hot bodies radiate heat. When this heat falls on some object, a part of it is reflected, a part is absorbed, and a part may be transmitted. The temperature of the object increases due to the absorbed part of the heat. Why are you advised to use an umbrella when you go out in the sun? Figure 4.11. Sea breeze and land breeze. First scenario is of daytime. A house is close to a beach. A stream of arrows is coming from the beach towards the house. A picture below it makes us understand that cool air is coming from the sea towards the land and hot air is going from the land towards the sea. The second scenario is of night time. Now, a stream of arrows are going from the house towards the sea. This makes us understand with the help of second picture that hot air is coming from the sea towards the land and cool air is going from the land towards the sea. 4.5. Kinds of clothes we wear in summer and winter. You know that in summer we prefer light colored clothes and in winter we usually wear dark colored clothes. Why is it so? Let us find out. Activity 4.10. Take two identical tin cans. Paint the outer surface of one black and of the other white. You can observe this in figure 4.12. Pour equal amounts of water in each and leave them in the midday sun for about an hour. Measure the temperature of water in both the cans. Do you find any difference in the temperatures? In which can is the water warmer? You can feel the difference even by touching water in the two cans. Page 44. Figure 4.12. Containers with black and white surface. We often use electricity and fuels like coal and wood to keep our houses cool or warm? Is it possible to construct buildings that are not affected much by heat and cold outside? This can be done by constructing outer walls of buildings so that they have trapped layers of air. One way of doing this is to use hollow bricks, which are available these days.
Page 44.
Activity 4.11. Fill the two cans used in activity 4.10 with the same amount of hot water at the same temperature, say at 60 degrees Celsius. Leave the cans in a room or in a shade. Note the temperature of water after 10 to 15 minutes. Does the temperature of water in both the cans fall by the same amount? Do these activities suggest to you the reason why it is more comfortable to wear white or light colored clothes in the summer and dark colored clothes in the winter? Dark surfaces absorb more heat and therefore we feel comfortable with dark colored clothes in the winter. Dark surfaces absorb more heat and therefore we feel comfortable with dark colored clothes in the winter. Light colored clothes reflect most of the heat that falls on them and therefore we feel more comfortable wearing them in the summer. Woolen clothes keep us warm in winter. In the winter, we use woolen clothes. Wool is a poor conductor of heat. Moreover, there is air trapped in between the wool fibers. This air prevents the flow of heat from our body to the cold surroundings. So, we feel warm. Suppose you are given the choice in winter of using either one thick blanket or two thin blankets joined together. What would you choose and why? Remember that there would be a layer of air in between the blankets. Keywords: Celsius scale, conduction, conductor, convection, insulator, land breeze, radiation, sea breeze, temperature, thermometer. Page 45. What you have learned. 1. Our sense of touch is not always a reliable guide to the degree of hotness of an object. 2. Temperature is a measure of the degree of hotness of an object. 3. Thermometer is a device used for measuring temperature. 4. Clinical thermometer is used to measure our body temperature. The range of this thermometer is from 35 degrees Celsius to 42 degrees Celsius. For other purposes, we use the laboratory thermometers. The range of these thermometers is usually from minus 10 degrees Celsius to 110 degrees Celsius. 5. The normal temperature of the human body is 37 degrees Celsius. 6. The heat flows from a body at a higher temperature to a body at a lower temperature. There are 3 ways in which heat can flow from one object to another. These are conduction, convection, and radiation. 7. In solids, generally, the heat is transferred by conduction. In liquids and gases, the heat is transferred by convection. No medium is required for transfer of heat by radiation. 8. The materials which allow heat to pass through them easily are conductors of heat. 9. The materials which do not allow heat to pass through them easily are called insulators. 10. Dark colored objects absorb more heat than the light colored objects. That is the reason we feel more comfortable in light colored clothes in the summer. 11. Woolen clothes keep us warm during winter. It is so because wool is a poor conductor of heat and it has air trapped in between the fibers. Exercises. 1. State similarities and differences between the laboratory thermometer and the clinical thermometer. 2. Give 2 examples each of conductors and insulators of heat. 3. Fill in the blanks. A. The hotness of an object is determined by its blank. B. Temperature of boiling water cannot be measured by a blank thermometer. C. Temperature is measured in degree blank. Page 46. D. No medium is required for transfer of heat by the process of blank. E. A cold steel spoon is dipped in a cup of hot milk. Heat is transferred to its other end by the process of blank. F. Clothes of blank colors absorb more heat better than clothes of light colors. 4. Match the following. 1. Land breeze blows during. 2. Sea breeze blows during. 3. Dark colored clothes are preferred during. 4. Light colored clothes are preferred during. A. Summer. B. Winter. C. Day. D. Night. 5. Discuss why wearing more layers of clothing during winter keeps us warmer than wearing just one thick piece of clothing. 6. Observe figure 4.13. Mark where the heat is being transferred by conduction, by convection, and by radiation. Figure 4.13. In this picture, a container filled with water is being heated. 7. In places of hot climate, it is advised that the outer walls of houses be painted white. Explain. 8. 1 liter of water at 30 degrees Celsius is mixed with 1 liter of water at 50 degrees Celsius. The temperature of the mixture will be A. 80 degrees Celsius, B. More than 50 degrees Celsius but less than 80 degrees Celsius, C. 20 degrees Celsius, D. Between 30 degrees Celsius and 50 degrees Celsius. Page 47. 9. An iron ball at 40 degrees Celsius is dropped in a mug containing water at 40 degrees Celsius. The heat will A. Flow from iron ball to water. B. not flow from iron ball to water or from water to iron ball. C. Flow from water to iron ball. D. Increase the temperature of both. 10. A wooden spoon is dipped in a cup of ice cream. Its other end, A. becomes cold by the process of conduction. B. becomes cold by the process of convection. C. becomes cold by the process of radiation. D. does not become cold. 11. Stainless steel pans are usually provided with copper bottoms. The reason for this could be that A. Copper bottom makes the pan more durable. B. Such pans appear colorful. C. Copper is a better conductor of heat than the stainless steel. D. Copper is easier to clean than the stainless steel. Extended learning, activities and projects. 1. Go to a doctor or your nearest health center. Observe the doctor taking temperature of patients. Inquire. A. Why she dips the thermometer in a liquid before use. B. Why the thermometer is kept under the tongue. C. Whether the body temperature can be measured by keeping the thermometer at some place other than the mouth. D. Whether the temperature of different parts of the body is the same or different. You can add more questions which come to your mind. 2. Go to a veterinary doctor. He or she is a doctor who treats animals. Discuss and find out the normal temperature of domestic animals and birds. 3. Wrap a thin paper strip tightly around an iron rod. Try to burn the paper with candle while rotating the iron rod continuously. Does it burn? Explain your observation. Page 48. 4. Take a sheet of paper. Draw a spiral on it as you can observe in the figure 4.14. Cut out the paper along the line. Suspend the paper as you can observe in figure 4.14 above a lighted candle. Observe what happens. Think of an explanation. Figure 4.14. In the first picture, someone is cutting a spiral out of a green paper. In the second picture, the spiral is hanging over a lit candle. 5. Take two similar transparent glass bottles having wide mouths. Put a few crystals of potassium permanganate or pour a few drops of ink in one bottle. Fill this bottle with hot water. Fill the other bottle with cold water. Cover the cold water bottle with a thick piece of paper such as a postcard. Press the postcard firmly with one hand and hold the bottle with the other hand. Invert the bottle and place it on top of the hot water bottle. Hold both the bottles firmly. Ask some other person to pull the postcard. Observe what happens. Explain. Did you know? The Celsius scale was devised by a Swedish astronomer Anders Celsius in 1742. Strangely, he fixed the temperature of the boiling water as 0 degrees Celsius and of freezing water as 100 degrees Celsius. However, this order was reversed very soon. The chapter 4 of total 18 chapters of the book ends here.